What if the most dangerous weapon in the world isn't a gun, isn't a knife, isn't even hatred? What if it's 3 pounds of tissue inside the human skull? Why do some people feel fear and others feel nothing? Why does one mind recoil at violence, while another becomes calm, focused, even energized by it? Is evil chosen, or is it wired? And if parts of the brain can malfunction, can morality malfunction too? Tonight, we are not entering a crime scene. We are entering a nervous system, because somewhere between electrical impulses and chemical surges, between fear and thrill, between instinct and restraint, lies a question that has haunted scientists, psychologists, and investigators for decades. What happens when the brain's brakes fail and the accelerator gets stuck? Welcome to the circuitry of violence. Welcome to the homicidal brain. The human brain is the most complex structure in the known universe. 86 billion neurons communicating through electrical sparks and chemical whispers. Every thought, every memory, every moral hesitation, all of it is wiring. Most of us move through life with invisible safeguards. When anger rises, something inside slows us down. When temptation appears, another system weighs the cost. When danger approaches, fear tightens our chest and tells us to step back. These are not abstract virtues. They are biological mechanisms. At the center of this system lies a small almond-shaped structure called the amygdala. Think of it as the brain's alarm bell. It scans constantly for threat, a raised voice, an aggressive posture. Even a sudden movement, the amygdala activates. Before conscious thought even catches up, it floods the body with signals. Heart rate increases, muscles tense, pupils widen. Prepare, protect, survive. For most people, this system prevents violence more often than it causes it. Fear of consequences, fear of pain, fear of moral violation. These sensations create hesitation. But what if that alarm is quieter than normal? Studies of violent offenders have shown something chilling. Reduced amygdala responsiveness. When shown images that trigger fear or distress in most people, their brains react with muted activity. The emotional volume is turned down. Imagine touching a hot stove and barely feeling heat. Would you pull your hand away as fast? Now shift your attention to the prefrontal cortex, the region just behind the forehead. This is the executive center, the judge, the strategist. It calculates long-term consequences. It suppresses impulses. It asks, is this worth it? If the amygdala is the alarm, the prefrontal cortex is the brake pedal. When functioning properly, it regulates emotional storms rising from deeper brain regions. Anger flares, but the prefrontal cortex evaluates. Desire spikes, but the prefrontal cortex delays. However, brain imaging has repeatedly shown that in individuals with histories of extreme violence, activity in parts of the prefrontal cortex can be significantly reduced. Structural differences have also been observed: thinner gray matter, weaker connectivity. Picture a high-performance engine paired with worn brake pads. The vehicle can accelerate rapidly, but stopping requires more distance, sometimes too much distance. And then there is the reward system. Deep within the brain, circuits evolved to reinforce survival behaviors. Eating, bonding, achieving, these actions release dopamine, a neurotransmitter associated with motivation and reward. It teaches the brain what to pursue. Now here is where it becomes unsettling. If dominance, aggression, or the infliction of harm triggers dopamine release in a particular brainless system begins associating violence with reward, not morally, neurologically. Dopamine does not care whether the behavior is compassionate or cruel. It only strengthens what produces stimulation. For a brain wired toward thrill-seeking, high arousal states can feel intoxicating. Elevated heart rate, narrowed focus, adrenaline flooding the bloodstream. These sensations can create a heightened sense of clarity. Time may feel slower. Perception sharpens. The individual may report feeling intensely alive. To most of us, that state is terrifying. To some, it is magnetic. Combined reduced fear response, impaired impulse control, and heightened reward sensitivity, and you begin to see how vulnerability forms. Not destiny. Vulnerability. This is crucial. Biology is a predisposition, not a verdict. Many individuals possess one or even two of these traits and never harm anyone. Protective factors matter. Stable attachment, emotional regulation training, social bonds, moral development, conscious choice. But when early trauma disrupts development, the equation shifts. Chronic childhood stress alters cortisol levels, which in turn influence brain maturation. Prolonged exposure to violence can desensitize the amygdala. Inconsistent caregiving can impair emotional regulation. Neglect can stunt prefrontal development. The brain adapts to survive the environment it grows in. If the environment is chaotic, the brain may prioritize vigilance over empathy. If aggression ensures safety, aggression becomes reinforced. If emotional suppression reduces vulnerability, empathy may dull. Neural pathways strengthen with repetition. The brain is plastic, constantly rewiring based on experience. Thoughts become habits. Habits become circuitry. Imagine walking through a forest. The first time you push through branches. The second time, it's easier. After 100 times, a trail forms. Violence can follow the same principle. The more aggression is rehearsed, in behavior or even fantasy, the smoother the neural trail becomes. But again, rehearsal does not eliminate responsibility. Because awareness exists, choice exists. Even within biological constraints, the prefrontal cortex, however impaired, is rarely absent. It may struggle, it may be weakened, but it is not erased. The horror of the homicidal brain is not that it removes humanity. It is that it distorts it. The individual may still experience attachment, still laugh, still function, which makes the contrast even more unsettling. The same brain capable of tenderness may also harbor circuitry that, under specific triggers, overrides restraint. Violence rarely erupts from nowhere. It is often preceded by escalating fantasies, emotional desensitization, and a gradual erosion of inhibition. The internal dialogue shifts, justifications form, blame externalizes, and inside the skull, microscopic electrical impulses travel along, pathways carved by years of reinforcement. No lightning bolt, no supernatural takeover, just neurons firing in patterns that have been practiced. Science does not strip away horror. It makes it more intimate. Because if violence can be traced to circuitry, then the battlefield is not only societal, it is neurological. And the question grows heavier. If we can map the wiring, can we intervene before it ignites? Or are their brains already ticking silently, waiting for the right combination of trigger and opportunity? The answer lies deeper. If segment A exposes the wiring, segment B enters the voltage. Because structure alone does not kill. Activation does. A brain can carry vulnerabilities for years without crossing a line. reduced fear response, impaired impulse control, heightened reward sensitivity. These are risk factors, not guarantees. The true shift happens when stress, opportunity, fantasy, and biology collide at the same moment. Think of the brain as a control room filled with switches. Most people have a clear hierarchy. Emotion sends signals, but the executive center reviews them before action. In a dysregulated system, that hierarchy weakens. Signals bypass review. The emotional surge outruns reflection. One of the most studied patterns in violent offenders is impaired connectivity between the amygdala and the prefrontal cortex. It's not just about size or activity, it's about communication. If the alarm system and the brake system cannot synchronize, emotional arousal may not be effectively regulated. It's like receiving a fire alert but having the sprinkler system disconnected. Now add stress. Acute stress floods the body with adrenaline and cortisol. These chemicals sharpen attention and prepare for immediate action. In controlled amounts, this is survival. In chronic amounts, it reshapes neural pathways. The brain begins prioritizing rapid response over careful reasoning, reaction over reflection. For someone already prone to thrill-seeking, stress can become fuel rather than deterrent. The increased heart rate and heightened awareness may feel empowering. Instead of alarming, the brain learns to associate chaos with clarity. And then there is fantasy. Before violent acts occur, they often exist internally first. The imagination rehearses scenarios. Control, domination, revenge, rehearsal strengthens neural circuits just like physical practice. Visualization activates many of the same pathways as real experience. The more detailed the fantasy, the more entrenched the pathway. At first, the fantasy may serve as emotional release, a way to vent anger without consequence. But repetition changes its emotional texture. It becomes less shocking, less disturbing. The amygdala's response diminishes. Desensitization sets in. Meanwhile, the reward system notices something else. Anticipation. Dopamine spikes not just during action, but before it, during expectation. Planning can produce stimulation. The mind begins chasing the build-up itself. The fantasy becomes a loop. Imagine, feel, surge, reinforce pathway. In healthy development, empathy acts as a counterweight. Mirror neurons activate when we see others in pain. We feel discomfort, guilt, concern, but empathy can be blunted through repeated exposure to violence, neglect, or dehumanization. If others are cognitively reframed as objects, obstacles, or symbols, the emotional brake weakens further. Dehumanization is not just ideological. It becomes neurological. Language reshapes perception. If a target is seen as less than human, the emotional alarm does not sound as loudly. Then comes impulsivity. Impulse control relies heavily on the prefrontal cortex. Damage, underdevelopment, or chronic stress can impair its efficiency. The person may understand rules intellectually but struggle to delay gratification emotionally. They know consequences exist, but in high arousal states, long-term outcomes feel distant, abstract. This is where timing matters. Violence often occurs in moments of peak arousal combined with perceived opportunity. A trigger event, humiliation, rejection, threat to ego activates deep emotional circuits. If impulse control falters and empathy is muted, action becomes more likely. But there is another layer, identity. Some individuals gradually integrate aggression into their self-concept. They begin to see themselves as dominant, feared, powerful. The brain reinforces behaviors that align with identity. If violence strengthens that identity, it becomes self-rewarding beyond chemistry. It becomes narrative. The story inside the mind shifts from "I did something wrong" to "this is who I am." And the more the behavior aligns with identity, the less internal conflict arises. Reduced conflict means reduced stress signals. Reduced stress signals mean less amygdala activation in response to moral violation. The act feels smoother. Neuroscience has shown that repeated behavior strengthens white matter tracts, the communication highways between regions. The more a pathway is used, the more efficient it becomes. This applies to compassion. It also applies to cruelty. Yet here's the part that resists simplification. Not all violent individuals show identical brain patterns. There is no single killer brain. Some display heightened emotional reactivity. Others display cold detachment. Some act impulsively. Others plan meticulously. The homicidal brain is not a template. It is a spectrum of vulnerabilities interacting with environment and choice. Consider the role of serotonin, a neurotransmitter linked to mood and inhibition. Low serotonin levels have been associated with increased aggression and poor impulse control. But again, association is not destiny. Many individuals with similar profiles never harm anyone. Protective experiences matter. Support systems matter. Personal decisions matter. Biology loads the gun, some say. Environment aims it. But choice pulls the trigger. Even in individuals with structural differences, moments of awareness exist. Interviews with violent offenders often reveal internal conflict. Before the act, hesitation, rationalization, suppression of doubt. The moral voice may be quieter, but it is rarely absent. This is why neuroscience must walk carefully. Explaining mechanisms does not erase accountability. Understanding circuitry does not absolve action. It clarifies risk, not responsibility. The chilling truth is this: extreme violence can emerge when fear diminishes. Reward intensifies, empathy dulls, impulse control weakens, and identity embraces aggression, all under the right external pressure. No single factor creates it. It is convergent. Electrical impulses misfiring alone do not produce horror. But when misfiring aligns with narrative, stress, opportunity, and rehearsal, the threshold lowers, and thresholds matter. Every brain has a threshold for action. For most people, it is extraordinarily high when it comes to killing. The emotional, moral, and social costs feel overwhelming. In a dysregulated system, that threshold can erode gradually, not overnight, not dramatically, but incrementally. Each rehearsal, each justification, each desensitizing exposure. The barrier thins until one moment carries less resistance than all the moments before it. Science does not give us monsters. It shows us mechanisms. And mechanisms can be strengthened, weakened, redirected, which raises the next terrifying question. If the brain can adapt toward violence, can it adapt away from it? Or once certain pathways are carved deep enough, does reversal become almost impossible? The answer lies in plasticity and in limits. If segment B showed how the switch can flip, segment C asks the question that refuses to stay quiet. What happens after the first time? Because the first act is rarely the most psychologically revealing. It is what follows that exposes the true architecture of the mind. After extreme violence, most human nervous systems collapse under shock. Adrenaline fades. Cortisol lingers. The body trembles. The mind replays. Guilt surges. Fear of consequence becomes overwhelming. Sleep fractures. The amygdala lights up at every sound. The prefrontal cortex scrambles to process what has been done. But in certain brains, something else can occur. Instead of collapse, there is calm. Instead of horror, there is clarity. Instead of guilt, there is relief. This response has fascinated neuroscientists for decades. Why would an act that should trigger moral distress produce stabilization in some individuals? The answer lies in resolution of tension. Before the act, there is often mounting internal pressure rage, humiliation, obsessive rumination, perceived injustice. The brain remains in heightened arousal, cycling through imagined scenarios. The stress loop does not close. The body stays in fight mode without release. When the act occurs, that loop closes. The sympathetic nervous system, which had been braced for confrontation, discharges its stored energy. Dopamine spikes. The stress narrative concludes. The mind experiences completion. Completion can feel like peace. This does not mean pleasure in a simplistic sense. It means the end of unbearable internal noise. For some individuals, that silence becomes reinforcing. Reinforcement strengthens circuitry. The brain remembers what reduced tension. If violence reduced tension once, it becomes encoded as a viable strategy. Dangerous, distorted, but neurologically stamped. At the same time, another process unfolds: moral disengagement. Psychologist Albert Benula described mechanisms through which individuals detach from ethical standards euphemistic labeling, displacement of responsibility, dehumanization of victims, diffusion of blame. These are not abstract theories. They are cognitive tools the brain uses to reduce cognitive dissonance. Cognitive dissonance is the discomfort of holding conflicting beliefs. I am a good person, and I committed a violent act cannot coexist peacefully. The brain seeks resolution. It can either accept guilt and fracture identity, or reshape the narrative to preserve self-image. Many choose narrative reshaping. The victim deserved it. Circumstances forced it. The system left no choice. Each justification reduces emotional friction. Each reduction quiets the amygdala's alarm. Over time, the moral boundary shifts, and then comes desensitization. The first exposure to violence, real or imagined, activates strong physiological responses. Heart rate spikes, muscles tense, breath shortens. But repetition alters response curves. The amygdala adapts. The same stimulus produces weaker arousal. This is neural habituation. Habituation lowers barriers. With lowered barriers, escalation becomes possible. What once shocked now feels tolerable. What once felt extreme now feels insufficient to produce the same dopamine surge. The reward system demands more intensity for the same effect. This pattern mirrors addiction. Addiction is not limited to substances. It is a cycle of anticipation, action, reward, and craving. The brain begins prioritizing the behavior despite consequences. Prefrontal regulation weakens under repeated dopamine reinforcement. In some violent offenders, brain imaging studies show reduced gray matter in regions tied to empathy and impulse control. But more striking is functional connectivity. How regions communicate during decision-making. When empathy circuits fail to activate during moral reasoning tasks, the decision feels less emotionally charged. Emotion guides ethics. Remove emotional weight, and decisions become calculations. This is why some violent acts are impulsive explosions, while others are meticulously planned. The impulsive brain overwhelms the brakes. The calculating brain detaches emotion entirely. The latter can be more chilling because it demonstrates intact cognitive processing planning, foresight, strategy combined with emotional disengagement. The individual understands consequences, but values internal reward or ideology more than external cost. Ideology deserves attention here. Belief systems can powerfully reshape neural priorities. When aggression is framed as righteous, protective, or necessary, the prefrontal cortex aligns action with moral narrative. The brain no longer perceives contradiction. Violence becomes duty. Under ideological reinforcement, empathy may be selectively disabled. In-group members retain emotional protection. Out-group members lose it. This selective empathy is neurologically observable. Brain scans show different activation patterns when individuals view suffering of those they identify with versus those they do not. Identity sculpts empathy. Now consider childhood. Early trauma alters stress systems profoundly. Chronic exposure to threat keeps cortisol elevated. Over time, the amygdala may become hyperreactive, while the prefrontal cortex struggles to mature optimally. Emotional regulation skills fail to develop fully. Trust circuitry becomes distorted. Not all trauma leads to violence. Most trauma survivors do not harm others. But trauma can create vulnerability to dysregulation, especially when combined with neglect, instability, or exposure to violent models. Mirror neuron cells that activate when observing others. Actions help children learn empathy and social norms. If a child repeatedly witnesses aggression as problem-solving, those circuits encode aggression as viable behavior. The brain learns through modeling. Learning is powerful, but so is isolation. Social isolation reduces corrective feedback. In healthy communities, moral violations trigger social consequence, disapproval, exclusion, intervention. These signals recalibrate behavior. Isolation removes calibration. The individual becomes the sole narrator of their moral story. Without challenge, distorted narratives strengthen. And then there is the role of humiliation. Neuroscientific research suggests social rejection activates brain regions. Similar to physical pain, humiliation can feel like injury. For individuals with fragile identity structures, repeated humiliation may trigger rage circuits intensely. If revenge fantasies are rehearsed repeatedly, the brain binds relief to imagined retaliation. The line between fantasy and intention narrows. Yet even at this stage, intervention remains possible. Neuroplasticity, the brain's capacity to reorganize, does not disappear in adulthood. Therapy can strengthen prefrontal regulation. Mindfulness practices increase connectivity between emotional and executive regions. Medication can stabilize neurotransmitter imbalances. Supportive relationships can rebuild trust circuitry. The homicidal brain is not a permanent label. It is a description of patterns at a point in time. But there is a sobering truth. The deeper a pathway is carved, the harder it is to redirect. Repetition ingrains efficiency. The brain favors familiar routes. Creating new routes requires sustained effort, accountability, and often external structure. Which brings us to the most uncomfortable reality. Many individuals with violent tendencies function outwardly normal. They work, they speak politely, they blend. The brain's structural differences are invisible. There is no visible mark. Danger does not always look dangerous. The absence of visible distress does not mean absence of internal distortion. And this invisibility fuels public fear. People ask, can we detect it? Can we scan for it? Can neuroscience predict who will cross the line? Current science says no, not with certainty. Risk factors can be identified. Patterns can be studied. But prediction of individual action remains unreliable. Human behavior emerges from complex interplay, not single measurements, which means responsibility cannot be outsourced to brain scans. Society must address environment, early intervention, mental health access, trauma support, community connection, because the homicidal brain does not emerge in isolation. It develops in systems, and systems can either amplify vulnerability or buffer it. The real question now becomes even more unsettling. If we understand the pathways that strengthen violence, why does society still ignore the early signs? Why do we wait for catastrophe instead of investing in prevention? And most haunting of all is the potential for extreme violence locked inside. More minds than we are willing to admit, held back only by circumstances, morality, and thin but vital neural barriers. Before we end this chapter, sit with one final question. If violence can be mapped in circuits, if impulse can be traced to wiring, if thrill can surge through damaged pathways, then where does choice stand? Because this is the edge where science meets responsibility. Neuroscience can explain predisposition. Psychology can explain patterns. Biology can explain vulnerabilities. But none of them erase agency. And that distinction matters more than anything. Let us return to the brain one last time. Picture the amygdala as a fire alarm. In some individuals, the alarm is too sensitive. It screams at small sparks. Rage floods quickly. Fear spikes instantly. The body prepares for combat before thought can intervene. In others, the alarm is dull. It barely rings at scenes that would freeze most people. Blood does not shock them. Threat does not terrify them. The absence of fear can feel like power. Neither extreme is destiny. The difference lies in the prefrontal cortex, the command center behind your forehead, the moral brake, the strategist, the part that says, pause. Even when the alarm screams, the brake can still press ... Even when the alarm is silent, the brake can still evaluate. Impulse travels fast. Choice travels slower. But slower does not mean absent. Research consistently shows that violent acts often involve a window. Sometimes seconds, sometimes minutes, sometimes days, where intervention could occur. A phone call, a conversation, a cooling-off period, a removed weapon, a supportive present. Violence feels explosive, but it is rarely instantaneous from a neurological standpoint. There is build-up, rumination, rehearsal, physiological arousal rising in waves. And waves can crest or break. One of the most critical biological insights in violent behavior is impaired. Impulse control. This does not mean the person cannot understand right from wrong. It means the emotional surge overrides regulation more easily. Imagine driving a car with weakened brakes. You can still steer, you can still choose direction. But when speed increases, stopping requires more force. Many people live with weakened brakes due to trauma, substance abuse, neurological injury, or developmental factors, and yet never commit violence. Why? Because environment matters. Stable relationships strengthen regulation. Support systems help absorb emotional spikes. Clear consequences reinforce boundaries. Structured routines reduce chaos. The brain does not operate alone. It operates in context. Remove context, isolation, humiliation. Chronic stress and the strain on those brakes intensifies. Add substances like alcohol or stimulants, and inhibition drops further. The prefrontal cortex becomes less active. The amygdala gains dominance. Reaction outpaces reasoning. This is not an excuse. It is a mechanism. Understanding mechanism allows prevention. Now consider something deeply uncomfortable. Thrill-seeking behavior shares neurological pathways with extreme violence. Higher-risk sports, gambling, dangerous stunts all stimulate dopamine circuits. Most thrill-seekers channel this into controlled environments. But when thrill intersects with aggression, the brain can link dominance with reward. Power can become intoxicating. Dominance activates ancient circuitry tied to survival hierarchies. In evolutionary terms, dominance once meant access to resources and security. In modern society, those drives are constrained by law and ethics. Yet the circuitry remains. In certain personalities, particularly those high in psychopathic traits, reduced fear response combines with heightened reward sensitivity. Fear does not inhibit them the way it inhibits others. Risk feels stimulating, not paralyzing. Imagine standing at the edge of a cliff. Most people step back. Some feel a pull. That pull is not inherently evil. It is sensation-seeking. But if sensation-seeking merges with dehumanization, if another person becomes a means to stimulation, the equation darkens. Dehumanization is one of the most powerful psychological mechanisms behind extreme violence. When the brain categorizes someone as less than fully human, empathy circuits dampen. Moral restraint weakens. History offers tragic examples: genocide, war atrocities, systemic brutality. Entire groups convinced themselves their victims were vermin, threats, obstacles. When language strips humanity, violence becomes easier. And here is the chilling truth. The same neural architecture that allows love allows hate. The same brain that bonds can detach. The same circuits that protect can destroy. Human biology is not divided into monsters and saints. It is built from adaptable systems. Adaptability is our strength and our risk. So how do we prevent the homicidal pathway from strengthening? Early intervention. Childhood environments that teach emotional regulation. Safe attachments that model empathy. Conflict resolution skills practiced repeatedly. Mental health care accessible without stigma. Communities that notice warning signs before they escalate. Warning signs often appear as patterns. Escalating aggression. Fascination with dominance and control. Chronic resentment narratives. Isolation paired with grievance. Rehearsed revenge fantasies. Not all who show these signs become violent, but these are moments where support, therapy, and accountability can redirect trajectory. Neuroplasticity never fully disappears. The brain can form new pathways. Emotional regulation can improve. Empathy can strengthen. Impulse control can be trained. But change requires willingness, and society must balance compassion with boundaries. Understanding the homicidal brain does not mean minimizing harm. It means preventing it. It means recognizing vulnerability without surrendering moral standards. Because here is the final, unavoidable reality. Predisposition is not permission. Biology loads the gun. Environment steadies the aim. But choice pulls the trigger, and choice exists. The most terrifying myth is that violent individuals are entirely different. Species born evil, unreachable, alien. That myth comforts us because it creates distance. But neuroscience dismantles that illusion. The wiring differences are often subtle shifts along spectrums we all share. Fear, anger, desire, dominance, thrill. The line between ordinary and extreme is not a wall. It is a boundary maintained by regulation, empathy, accountability, and social structure. Thin, but powerful. The homicidal brain is not a horror story hidden in darkness. It is a cautionary map of what happens when regulation erodes, empathy collapses, and reinforcement strengthens destructive circuits. Science does not strip away responsibility. It sharpens it, because if we understand the wiring, we are obligated to strengthen the brakes. If we understand the triggers, we are obligated to reduce them. If we understand vulnerability, we are obligated to intervene early. The question is no longer why do they do it? The deeper question is, what are we doing, individually and collectively, to ensure the wiring of violence never completes its circuit? This chapter ends not with fear, but with awareness. And awareness is the first safeguard against darkness.